I have a pendulum which is deflected by angle theta naught like this. You all know if you release this or if you give it velocity in this plane. This plane is which plane? The plane where this vertical line and this pendulum is. In that plane, if you give velocity, what will happen? It will go this way, it will oscillate this way. Yes or no, students? So that we have done in already vertical circular motion. Correct or not? What I am going to do is I am going to give it a speed into the board. Like this. Ready? So if I give it like deflection and then no speed, it will stay in this vertical plane. If I give speed in this vertical plane only, it will stay in vertical plane. But if I give it speed perpendicular to this vertical plane, are you listening? Perpendicular to this plane, like this, see. Ooh, something very nice happened there. That was the actual question. But there is one nice speed you can give that will make it go in constant angle. That is called conical pendulum. Conical pendulum means your pendulum will move with constant angle. But here friction is there, so ultimately it will stop. What angle will move? Constant angle. Are you understanding? So we want to find the speed, find V naught, so that it behaves, it matlab who here students, fast you tell, we don't have time. It behaves, pendulum behaves like conical pendulum. Conical pendulum is a very special case. So there is only one speed at which it will behave that way. That speed we want. So we want it to go something like this. Everybody clear? So when it is here, angle should be what? Constant. So it makes constant angle with vertical. So since it is moving with constant angle and speed, whatever acceleration it will have should be towards the center, centripetal. So let's search for forces who will provide that acceleration, centripetal. So here tension, here mg. Since we want acceleration this side, we will take components of tension. So here T cos theta naught, here T, how much? Sin theta naught. Quickly tell me, who will balance mg? T cos theta naught. And this side, should you balance forces or you should apply F equal to ma? This side you should balance forces. Then who will provide acceleration? From ground frame we are doing, no? Of course, if you sit in this particles frame, then here you will show pseudo force. Then that pseudo force and this tension should balance if you study from non-inertial frame. But let us study from ground frame. In ground frame we apply F equal to ma wherever there is net force. So T sin theta will provide what force? Centripetal force. R means which R? I hope you all understood. Do not confuse R with length of the pendulum, students. They will give you what of the pendulum in exam? Length, because length of pendulum will be fixed during this motion. Here the R is also fixed. So L theta naught. Can you tell me what is relation between these two? R will be what? L sin theta naught. Okay. So how to find V naught? What is the unknown here? T is unknown, theta naught was given. So let us divide. Let us divide these two. What will you get? Tan theta naught. Tan theta naught will be what? V naught square by Rg. So what will be V naught? Under root Rg tan theta naught. What is small r? L sin theta naught G tan theta naught. So at this speed, if you give this much speed, exact this much speed only, for any angle, you can find that speed. First decide at what angle you want it to go, ma. First decide that. You want it to go this way or this. First find the angle. Once you decided the angle, by the way, you can't make angle 90 degrees, sorry, tan 90 will be infinite. You have to give infinite speed, obviously. Because if you want it to go like this, who will balance mg? Then if it goes like this, then tension will be here. Then who will balance mg? So it has to be slightly what? Slightly down. This will be slightly down, slightly down. The faster you move, it will look like horizontal exact. It will look like this string is like this, but the string will be slightly dipped. Without that, there is no chance mg will be balanced. Now, Irodov in his book has asked a similar question, except what he has done, he is asking what speed you should give so that starting from this angle, it should become 90 degree. This should become 90 degree. That is what happened with Krutik's ID when I gave. Did you notice? Did you notice when you saw? It went, wait once more. We'll try. Now, if I can give this much speed, I don't know how much is that speed, then it will go in nice conical pendulum. But if I give more than that speed, see. You understood what is happening. So, if you give more than this speed, then what will happen? You only think this will become more than this, because this is fixed at that angle. For this angle, t sin theta is fixed. But there you are giving more than that speed means this will not be able to provide this. It's like there is a fixed speed at which you should turn in a circular road. If you go more than that speed, what will happen? Hospital. Matlab, you will not be able to go in that circle. You will go much bigger circle. Then once that happens, what will happen? Once this becomes greater than this will increase, this angle will increase. But you get this speed also. So it will go inside the board also, but with increasing angle. But as angle increases, speed will start decreasing. Yes or no? And then at some maximum height, it will reach and then come back. Now at that maximum height, will it have speed or not? That is the interesting question. Be careful. It is not a pendulum which is going like this. If this was the case, then obviously at maximum height, it will have no speed. In gravitation chapter, if this is your earth, and you want satellite to go in a perfect circle, like this before, like this conical pendulum, you did not want angle to change. If you want that to happen here, then you have to give the satellite one particular speed only. Only at one particular speed, it will go in what? Circular orbit. They will ask you what is the formula for this speed. Very simple. Who will provide centripetal force? Gravitational force. What is gravitational force between Earth and satellite? It can be sun and planet also. Sun and planet also. So tell me gravitational force. First write Newton's law first. Gravitational force will provide centripetal acceleration. Uniform circular motion this is. So tell me gravitational force. Gmm by radius of the orbit square equals to m. What is centripetal acceleration? V square by r. M 1 r cancel. So what is orbital velocity? Under root gm by small r. Did you notice that for 1 r you have 1 v naught? For that r, there is only one V naught where this equation will be satisfied. Now suppose you burn gases here. You burn rockets in backward direction that to provide impulse here. What will that do? It will increase the speed suddenly here. Once speed increases, it will try to go in bigger orbit. So it will go away like here. Once you give speed more than that, your theta increased. Before theta was fixed. Like before r was fixed, now your r will increase suddenly. So your orbit will now look like this. Your orbit will now look like this. It will start moving in ellipse. You will start moving in ellipse. If you give it what speed? Greater than orbital velocity. But don't make it greater than escape velocity also. Then it will go in hyperbola. Equal to escape velocity, parabola. If you give it exactly escape velocity, parabola. If you give it more than escape velocity, it will go hyperbola. This is parabola. Now, why I am saying this topic here is because, see students, you also think what is happening, all of you. When you increase the speed here, it started going this way. Now, if I draw this line, can you see the velocity will have one component here, one component here. This component is along this radial line, though this is not radius because this is no longer circle. It is along the line joining them. So if there is velocity away in this line, what does it mean? Gap will increase till where it is increasing, till it reaches here. You see here what happened? Velocity will become like this. Now does it have any component here? No. Then the gap will start decreasing. But though it has reached highest point in a way, this is not highest point unless you stand like this on earth. If you are standing like this, then this point will become highest point for you. So at highest point, though it doesn't have velocity in this direction, it still has this velocity. Same thing happens here. If you give speed more than this, it will start from here like this, then go like this, and then stop and then come like this. So if this is your vertical plane, here there will be one velocity which will start the motion. When you reach here, there will be one velocity this side, one velocity either here or here. This velocity will either increase or decrease the angle, and this velocity will take it this way. So you always need velocity perpendicular to this plane, the vertical and the pendulum. So think of a plane made by this vertical line and this pendulum. So here this speed will be there, then after some time when it is here, this speed will still be there. Now why that speed has to be there? Because, done this problem? Okay, so let us create the question which Irodov has asked. So the question is like this, all of you. A pendulum starts at some angle theta like this. It is deflected at some angle theta. You have given a speed perpendicular to this vertical plane. Question is, what should be this plane that as it moves, it should reach 90 degrees. Here it should reach, they are asking. But this is after going back. It is not going this way, students. It is going this way. What should be V so that this pendulum reaches here? What I am trying to tell you is, when the pendulum reaches here, this velocity which increases the angle will become 0. So the velocity which increases the angle will become 0. Because it goes to max, like here. Like in this diagram, when it reaches here, this component becomes 0. Which increases the radius, I should say not radius, which increases the gap. So here, which increases this theta, that speed will become 0 when you reach the highest point. However, there will be, as Anish told, one velocity out of the board, V dash. That has to be there, students. Now you will say, why it has to be there? Like in that case, it has to be there, that V. Otherwise, it will go straight towards Earth. And there, the reason why V has to be there is because of conservation of angular momentum. Now, you tell me, no matter where is the particle, no matter where is the satellite, the force will be always towards Earth. So, what will be torque about Earth? Torque about Earth. What will be torque about Earth if force is always passing through Earth? If torque about Earth is 0, angular momentum about Earth will be constant. That means MVR should be constant. That means when your R increases, your V should decrease. Understood? So here your R is less, V will be more. Here R is more, V will be less. But still you need V. If V becomes 0, then what happened? Angular momentum becomes 0. But angular momentum should be conserved. Whatever was here should be here also. So you can't suddenly have V0. That V which gives angular momentum. Now come to this problem. Tell me which force will create torque about this point. After learning so much about torque, please tell me which force will create torque about this point. Mg. Because tension will pass through that point. Now tell me direction of that torque. About it. This is your R. Or if you draw this line, this is your R perpendicular. So R cross F into the board. So torque is where? Into the board. Same thing will happen when the pendulum was, suppose, let's say the pendulum was going like this and coming here. So if the pendulum was coming here, this is your R vector. So R cross F out of the board. That means when it was back side, where will be torque? That side. Meaning, no matter where is torque, it is always horizontal. Torque vector I am saying is always horizontal. So if torque is always horizontal, what is component of torque along vertical? Component of torque along vertical? 0. That means angular momentum along vertical must be constant. End of story. And if angular momentum is constant like there, your V cannot be 0. If V becomes 0, angular momentum becomes 0. So one component though has to be there. Okay. So now finished. Let us apply L coarm. Between which point? This point and this point. Tell me angular momentum about which axis I want? Vertical axis. Be careful. So when our bob is here, where is angular momentum? Let me show you this side. This is the point about which I want angular momentum. This is our bob. Right now it is going inside the board. Into means what? Inside the board, this is L. So L cross V this way. So your angular momentum is this way. Guys, you understood? R, L bar cross V bar. About this point, particle is here. This is R bar. This is velocity vector V bar. Make the tails meet. Now rotate your fingers from here to here. Where it will be? Cross product anyways you know is perpendicular to the plane containing the two vectors. So L bar, V bar. Can you tell me where it is? L cross V. Here. And which component is conserved? This is not conserved. Which is conserved? This component is conserved. Let's say Z component. If I call this axis Z axis. Now tell me what is angular momentum magnitude? MVL. Because L and V are perpendicular. L is in the board. V is perpendicular to the board. So 90 degree. Now if this angle was, starting angle was theta by ancient Greek rule, this is perpendicular to this. This is perpendicular to this. So this will be also theta. So what will be this component of angular momentum in vertical direction? MVL sin theta. So angular momentum along vertical, that is conserved, remember, not this one. So what is the angular momentum in vertical direction? This should be constant, I told. So when it was here, what is the angular momentum? MVL sin theta. Here, when it reaches here, that is easy. Where is velocity? I told. Out of the board. This is L. V is here. So what is angular momentum here? V is here. So L cross V. Out. So what is that angular momentum? M V dash L. So MM cancel, LL, cancel. What will be your V dash? V sine theta. Our aim was to find what? V. Theta was given. V dash is also there. So now one more equation we need that will easily come from conservation of mechanical energy, because tension will not do work, I told. So from here to here, let us use conservation of mechanical energy. Can you tell me directly how much height it gained? This much height it gained. This was here, now it is here. So how much height it gained? This is L cos theta. So let us do direct conservation of energy. Potential energy gained, kinetic energy lost. So how much potential energy it gained? mg L cos theta. How much kinetic energy it lost? Lost matlab always initial minus final. Initial kinetic energy was half m v square. Final was half m v dash square. M cancel. Let us substitute. GL cos theta is equals to V square by 2. What is V dash? V square sine square theta by 2. Multiply with 2. 2GL cos theta is equals to V square bracket 1 minus sine square theta. What is 1 minus sine square theta? Cos square theta. Sir, where is this 2? Here, bro, here. 1 cos, cancel. What V came? What V came, students? Under root 2GL by cos theta. Students, can you remind me what was V naught to go in conical pendulum? What was the right speed I have to give at that angle? It was, I think, GL tan theta sin theta, which can be written sin square theta by cos theta. So if this speed was given, it will not perform this way. It will perform in a nice conical motion, like in the satellite case, nice circular orbit. But you have given more than that speed, so that extra kinetic energy does all these things. It increases the potential energy more than what it should have been, or it would have been if it was conical pendulum. Now check. The speed that you have given in this problem is more than this or not. Check. GL by cos theta, GL by cos theta. To go in conical pendulum, this should be sin square theta. But you have given 2 here. And 2 is obviously greater than this sin square theta for any theta. Okay, write down gravitation.